teacher. This is the Test 1 review. This is the paper copy, so when you go to do your online version, the numbers will be different. So your online test review, you have to do, it's the most important thing this semester. You have to do your test review online to gain access to your first test. If you do not do the online test review for a 70 or more by the due date, then you cannot ever take your test and you will always have a 0. So that online test review is the key or the gateway to gaining access to your test. Okay, and this paper review that I'm doing right now is similar, but just different numbers. So your online review will say, number 1, factor the trinomial, only it'll have different numbers here. That's all it is. Okay, for number 1, it says factor the trinomial. First things first, alert, alert, alert. This is not in the correct order. It looks funky. We're supposed to have the squared thing first. So we got v squared, then the regular v thing next, minus 4v, then the naked number, minus 12. This is called decreasing order of exponents. Okay, and this is how it's going to be on your test. So on number 1 on your test, if you don't put it in the correct order, you're going to get it wrong. 100%, I guarantee you. Okay, now what we're going to do is we're going to find two numbers that add to -4 and multiply to -12. Okay, and to find the two numbers, I know you're really starting to say, oh, okay, things that add to 4 are 2 and 2. Yeah, that's great. But we want to start breaking on the multiply. So what multiplies to a 12? Well, 12 and 1. But could those ever add up to this 4? No, they couldn't. So let me try another break. Maybe, so 12 and 1 are not going to work. What else multiplies to 12? Well, a 4 and a 3. But will those ever add up to this middle 4? No. What else multiplies to a 12? A 6 and a 2. That's what we're going to use, a 6 and a 2. The question is whether we use plus or minus. Okay, so we're going to start out with 2 sets of parentheses, and this is what you would type in, parentheses v, blah, 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 parentheses v, blah, 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 blah. Okay, then we set our two numbers are 6 and 2, but we want to be able to add or subtract to get -4. Okay, well, if I use positive 6 and -2, let's see what happens. Oh my gosh, okay, come on, okay, -6 plus 2. Oops, that's the wrong one, but -6 plus 2 gives you -4, whereas positive 6 minus 2, if I reverse the symbols or if I change the symbols, I get regular 4. Well, I want the -4, so I'm going to use this -6 plus 2. So big fat minus, big fat plus 2. Hey-o, that's our answer. Yes. Okay, so just be careful. On your test, it's not going to be in order. You have to put it in order or you're probably going to get it wrong. Second, pick the pair of numbers that multiplies to that last and adds to that middle. Okay, let's look at number 2. Number 2's kind of small, so I put it big. Woo, okay, so here's your number 2. And number 2 was asking a bunch of hoopla about limits around the 0. Just bear with me, okay? Yeah. All right. Okay, so on number 2, they give you these prompts. Okay, first off, limit means you're finding the y. So limit means you're looking for the y value. Okay, when x approaches, this x arrow 0 means we're going to be looking when x is 0. This negative means not negative, it means the left side, or look to the left of 0. Okay, for this limit below, it says x approaches 0 from the plus. That means we look at the right side of 0. Okay, this third one says x approaches just 0. Just 0. So that means we consider both of our previous answers to make up this answer, okay? And then for this F business, this is only talking about the closed dot at 0. This is how people get the test wrong all the time. This F business is only for closed dots. Okay, so let's get up on this sucker. We need to find when x is 0. Okay, well, x is 0. Let me maybe... Okay, it looks like this is the x-axis. You see it? It's kind of hard to tell. And this is the y-axis. And on your test, your picture's going to be kind of hard to tell like this. So you might have to trace over the x and the y, or trace over it with your finger on the computer. Okay, so we need to find when x is 0. X is 0 right up in the middle, right at the origin. Okay, and I want to know what is the y value for the piece that's connected to the left of 0. So I'm looking for, this is the left of 0. See that little piece of straight line thing? Yeah, okay. So the question is, what is the y value as we're getting closer to 0 of this left-hand curve? Well, the y value at this left-hand piece of the curve is just 0. Okay, let's look at the right-hand piece of the curve. Here's x is 0. To the right is this curve right here. Okay, so this is the right. And we are still looking for the limit, which means the y. Now, that doesn't mean the y value at this open hole. It means the y value at 0. So that y value when x is 0, here's x is 0, right up in the middle. The y value of this blue line, well, heck fire, it's right up in the middle. It's right there. It's the same spot. It's still the y value of 0. The only time the left and the right limits are different is when there's a jump. So we'll talk about a jump in a minute. Okay, now let's look at the limit as x approaches just 0. This is where we consider both of our previous answers. If our previous answers were the same number, and we have the same 0 for both of our previous answers, then that means our new answer is that same number, 0. So this is asking, okay, what's the y value of that left piece of the curve? 0. What's the y value of that right piece of the curve? 0. What's the y value when we look at it all together? Well, it's still 0. They touch each other. Okay. This F parentheses 0 means closed dots. Okay. At 0. And if we look at the picture, I kind of marked over it, but right at 0, there's no closed dot. There's one a little bit moved over to the right of it, but at this 0, there's no closed dot. Okay, here's the thing. For this F business, you either write down the y value at the closed dot at 0, or if you don't have a closed dot, you use the y value and you assume assume it's closed. Okay, so what that means is this right here, that's an open dot because you can see it with your face. This right here, that's a closed dot because you can see it with your face. When x is 0, because remember this number in the parentheses is the x, when x is 0, we're right here. I cannot see a closed dot. I can't see an open dot. I don't see anything. I just see this janky looking weird curve. Okay, and the y value when x is 0, if you can't see a closed dot, if you can't see an open dot, you assume it's closed and you write down that y value. Well, the y value here is 0. Yes. Okay, let's try another one. Let's look at number 3. The picture was too small, so I made it bigger. Okay, number 3 talks about that jump hoopla that I was mentioning earlier. Okay, number 3 is talking about the x approaching -2 from the left, the right, in general, and it says that F business. All right. So first let's find when x is -2. X goes side to side. Okay. -1 is here. -2 is here. Okay. All right. This little minus sign up in the air means we're looking at the left. So if this is -2, the curve to the left of it is this sucker. And it's saying, what is the y value at -2 for this curve? And the answer is, well, let's count down. Okay, so I went left 2. How much do you have to go down to get to that open hole? So left 2, down 1, 2. So this is equal to -2 because that's the y value at this open hole. Who cares whether it's an open hole? The only thing that the open hole affects is this F business, because this F business has to come from a closed dot or a closed hole, or from somewhere that you assumed was closed because there wasn't an open hole. Okay, so this is the left side of the curve. The y value when x is -2 is down 1, 2, -2. Okay, let's look at the next limit. It says plus sign. That means right. Okay, so let's go to -2 on the x-axis. Here's -2 on the x-axis. And we're going to look at the right side, the curve to the right of it, which is this piece of the curve. Okay, and it's asking when x is -2, what is the y value at that point? And the y value is still, we went left 2, down 2. It's still -2. Yeah. Okay, and then if we consider both, if we're looking for x approaching just -2 without the little left or right symbol, since our last two answers were the same, then our answer for this sucker is -2 again. And the only time this third answer would be does not exist is if there was a jump, and we'll talk about a jump in a minute. Okay, this F of -2 means the closed dot. Okay, so x is -2, so let's go to when x is -2. We already wrote it, it's right here. And then we have to find the y value of the closed dot. The closed dot at -2 is not this guy down here. It's this guy, whoa, way up here. And what's the y value at this closed dot? Well, it's up 1, 2, 3. So that sucker is 3 because it came from the closed dot. We do not put -2 because that came from the open dot. Okay, let's try a jump. Let's say I want to know what the limit as x approaches 1 from the right, from the left, in general, and that f business. Okay, so this plus sign means from the left. So let's go to and find when x is 1. X goes side to side. 1 is here. Okay. The plus sign means the right side. So here's when x is 1. I want to know the curve to the right and what the y value is when that curve stops at x equals 1. So this curve stops at x equals 1, and its y value looks like down 1, 2, 3, down 3, so -3. So this is equal to -3. Okay, now let's do the limit as x approaches 1 from the left. Okay, so that means you look for when x is 1, here it is. Look for the curve directly to the left of it, here it is. And we write down the y value when that curve stops at x equals 1. So this is when x equals 1. It's the left side, and I want to know what the y value is. Well, it's up 1, 2, 3, 4. Okay. Now the limit as x approaches just 1 in general, well, it does not exist because my curve jumps. I have this left-hand piece that gives me a y value of 4, but then it jumps and we have another y value for the right-hand side of the curve, and those are different. So that means we can't for sure tell you what the y value is at x equals 1 because there's 2 different points. So that's why it does not exist. Okay, f parentheses 1, remember that's when x is 1 and it only wants the closed hole. So let's look at when x is 1. Here it is. And it only wants the closed hole. So it's not this guy. We got to rise up. What's the y value at this closed hole? Up 1, 2, 3, 4, 4. So this is saying there's a y value at x equals 1 for the left side of the curve. Yeah, it was 4. For the right side of the curve, it's -3. If we're looking at the curve all together, there's not one y value right here. There's 2, so that's why it does not exist. And then the f business only talks about the closed holes. Okay, done with that one. Let's look at number 4. Number 4, we use this horrific equation. This formula was in your, I think, 9.1 and 9.2 notes, and I could tell who used PhotoMath because you got the answer in 15 seconds or less. And those of you who answered these questions with your PhotoMath in 15 seconds or less, it might hurt you on the test because you didn't do the work. So let's do the work, okay? This says find the limit as x approaches 0, blah, 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 and then it says f parentheses 6 plus h. This is the first thing we need to do. The very first thing we need to do is find f parentheses 6 plus h. Okay, well, I know what f of x is. F of x is negative 5x minus 7. So if I want to find f parentheses x plus h, I'm just going to take that x plus h and plug it into this x on the right side. Yeah. So instead of f parentheses x, we're going to have f parentheses, not x plus h, what was it? 6 plus h. 6 plus h. Okay. And then we're going to plug that 6 plus h in to this little x on the right side. So we're going to have negative 5 parentheses 6 plus h parentheses minus 7. All right, let's distribute and clean up. Don't forget we're multiplying this negative 5. Alert, alert. That's how you're going to do something wrong on the test. You have to multiply by a negative up in there. All right, so we get negative 30. Negative 5 times h is negative 5h. No multiply the 5 and the 7. We just drop down minus 7. Okay, combine like terms. I see negative 5h, and then I see negative 30 and minus 7. Okay, those make minus 37. Okay, the second thing we need to do is find f parentheses 6. Okay, so my second step is to find f parentheses 6. And we're going to do the same process. Just like on the first step, I replace the x with 6 plus h. Now I'm going to replace this x with 6. So negative 5 parentheses 6 close parentheses minus 7. And then let's do our math. PEMDAS says P, E, M. So multiply. You get negative 30 and then minus 7. And all together is negative 37. Huzzah! All right, the last thing that you're going to, well, not the last thing, but the next thing you're going to do is you're going to throw it all in that formula. It says limit as h approaches 0. And there's the formula. Okay, so let's see here. This 6f6 plus h hooey is what we got from our first step. So I'm going to put that negative 5h minus 37 right there. Okay. Then I have minus f parentheses 6. And for f parentheses 6, I got negative 37. Okay. So I'm going to write minus, because there's a minus up in the formula. See that minus, 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 minus. But then I have to write another minus because this 37 has it on him. Oh gosh. All over h. Okay, so why do I have two? Why are we double dashing? We have one minus from the formula. One minus from the 37. Okay. Let's see, those minuses make a plus. Yeah. And then heck fire, those 37s cancel out. How lucky are we? Okay. So my fourth step is just to try and make it smaller, make things cancel out. So we already canceled the 37s, and they better cancel. Okay. And then we have negative 5h over h. Well, what happens here? The h's cancel. So I just have limit h approaches 0 of, what does it say, negative 5? Good. Okay. My last step is to plug in the number 0 for the letter h, if we still have a letter h. We don't, because it got canceled. So the very last step is to plug 0 into the h if you got it. But we don't. Ours got canceled. Okay. So my answer is just whatever I had after the h is canceled. Negative 5. So my answer is negative 5. Hey. All right. Let's keep going. And on your cheat sheet, I would suggest you rewrite this whole problem and with any extra little notes to yourself that you need. Because on your test, number 4 is going to be this same problem, but instead of 6s and 5s and 7s, the numbers will be different. All right, let's keep going. Number 5 and 6. I went ahead and printed these out, I thought, because they're too small. Okay, number 5 says something about limit. I can never get the I in there right. Limit as x approaches infinity. Yeah, okay. Okay. So here's my graph. First, we need to find when x is infinity. Well, let me just trace the x and y axis. Here's the x and y. It's kind of hard to tell. Okay. I need color. All right, so we're looking for when x is infinity. Well, where is x? X goes side to side, but where is infinity? Infinity is, here's 2, 4, 6, 8, 10. Okay, here's 12, here's 14. Eventually, it's going to be infinity. Yeah. So when x approaches infinity, that means way over here on the right. It's saying, what is the curve doing as it keeps on going and going and going and going and going and going all the way to x is infinity. Okay, and remember, limit means y. So this is asking, when x is going to infinity, what will your y value be? Well, when my x is infinity over here by this arrow, the y value is, let's see, I have to go down 1, 2, 3, 4. The y value should be -4 right here. So the question was, what's the y value when x is infinity? Well, if you keep drawing this curve, x is infinity on the very right side. And the y value, we had to go down 1, 2, 3, 4. So that's why it's -4. Okay. Number 6 said, what's the limit as x approaches -2? Okay, well, let's remember, limit means the y value. X and the arrow -2 means that's where you look. Okay, and then also, we're missing that little plus or minus that's usually up there in the air. And that's important. Okay, let's remember, if there's a minus in the air, that means the left part of the curve. If there's a plus, the right part of the curve. If there ain't a minus or a plus, you have to consider both. And the only way you get an answer right here is if you had the same number for both of your previous, the left and the right. Okay, let's look at ours. I don't have a plus or a minus up in the air, so I have to consider both. And remember, when I consider both, they must be the same. Okay, so let's look at when x approaches -2. -2 is right when x is -2. Here's x is -2 right there. Okay, and I want to consider both sides. Well, let's see here. Let's look at this curve that's to the left of it. The curve to the left of it looks like it's coming down, and then it humps up, and it goes on forever, because there's a pretend arrow there. So, to the left of x value, of the x value of -2, the question is, what's the y value when that curve reaches -2? So So as we get closer and closer and closer to -2, I'm super close, but as I keep getting closer and closer to that dashed line of x equals -2, what is the y value doing? And the y value is going to infinity. Uh-oh. Okay, well, let's look at the right side. If I'm looking at the curve to the right, not this guy, no, not that guy, the guy immediately to the right, which is, here's the curve. Okay, so let's see, as I get closer and closer to that x value of -2, what is the y value at the end of my curve? Well, let's see, here's my curve, and as I'm super close to that -2 line, you see that orange line that I'm close to? As I get really close to that, what's your y value? And it's pointing down, so -infinity. Okay, now number 6 did not have that plus or minus up in the air, so that means you have to consider both, the left and the right. The limit from the left, or the y value on the left, was infinity. The y value on the right was -infinity. So if we're considering both, they are not the same, so it does not exist. All right, let's look at number 7. It says find the limits for the function f of x equals 2x over x minus 9. Okay, there's a couple of different ways we could do this. We could put it in our pictures, in our calculator, or we could use some paper pencil math. Let me show you the calculator way. Just in case. Okay, so I want to try and come up with a picture that looks like one of these past pictures, because then I can find my y value easy. I just have to look for it with my eyeballs. Okay, so I'm going to put this in the calculator. First, I'm going to press y equals, y equals, it's at the top left, y equals. Then I'm going to press, either you can press alpha x and it pops up little boxes for fraction, or you can press alpha y equals enter and it pops up little fraction boxes. Either way, we want little fraction boxes. So I'll press alpha y equals enter. Okay, now we're going to type in all of this equation, and we're going to use that xt theta button to put that x there. So on the top of my fraction bar, I have a 2, and then I'm going to use this xt theta. Okay, xt theta. Then drop down and put x minus 9. Okay, and then let's graph. Oh, my graph's not what I wanted. Okay. I've been messing around with my graph, so I need to zoom myself back to normal. So this is way too zoomed in. I'm going to press zoom 6, and it'll take me back to normal. Okay, let's look at this picture. It looks like the curve, something like that, right? Yeah, okay, that's what the curve looks like. Okay, if I want to see if there's any other curve, I can zoom out. Okay, but let's pay attention to what this curve is doing. This curve starts falling down. Let's see exactly where it falls down. At 1, 2, 3, 4, 5, 6, 7. Yeah, okay. Let me zoom out a little bit more because it's supposed to be 9. Okay, I'm going to press zoom and 3. Nothing happens because you have to press enter afterwards. Oh, look, there's the rest of my graph. Okay. So I typed in my goodies to y equals. Then I couldn't see everything. Darn. So I pressed zoom 3 and then enter. And now I can see the rest of my picture. Yeah. Okay, and the question is asking, what happens when x is 9? Okay, we can press this little right-hand arrow button, or we can press trace and then that little right-hand arrow button. And if we press trace and then that right-hand arrow button, you can see that the x values, as you keep pressing that right-hand arrow button, the x values say 4, 5, 6, 7, 8, 9, and then the little flashy button pops up to this other piece of the curve, and you can see that the x value is really close to 9. Or if we press second graph, oh my gosh, my calculator is so messed up. Well, okay, if we press graph, we see that at 9, there's an error. And that's what this gap is. Okay, the point is we need to figure out the limit, which is the y, the limit, which is the y, the limit, which is the y. And we have to do it for the, let's see, this first sucker says minus. So that means to the left of 9. Well, 9 is right here. And if you look at your calculator super close up, you can count the tick marks and see that it's 9 ticks to the right. Okay, so as our curve gets close to 9, what is the y value doing as we get closer and closer to 9? So I'm going to trace my curve from the left. I'm coming in from the left. I'm coming in from the left. I'm coming in from the left. Choo, 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 coming in from the left. And then as I get closer and closer to that 9, oh my goodness, my graph falls down to negative infinity. That is the limit as x approaches 9 from the left. Okay, now let's look at x approaches 9 from the right, because this says plus sign. Okay, that means from the right. I'm coming in, I'm coming in, I'm coming in closer to 9, I'm closer to 9, closer to 9, closer to 9, closer to 9. And I'm on the right because there was that plus sign in there. As I come closer to 9, oh my goodness, the graph rises up to infinity. So that's the answer for part B. But then the answer part C says just 9 in general. Well, this is what we've been talking about. Since there's two different y values, we're going to say that the limit, or the y value for the whole thing, does not exist. We only put an answer on that third choice without the plus or minus in the air if the last two answers were the same. Okay, let's keep going. Oh, my bad. Let me show you the mathy way to do this. Okay, the mathy way to do this, I forgot. I told you I would do that. Is, see how we have 2x over x minus... Nope. Use your calculator. Yeah, use your calculator. It'll be the easiest way to see it. Okay, and again, to get those fraction boxes, you have to press y equals alpha, y equals enter. And remember, if you don't have a calculator, you can use your phone app for now, but then when you get to the testing center, ask to borrow a calculator. Okay, and also when you call the testing center, ask them if you can borrow a calculator. Okay, number 8, it says give a limit expression that describes the right in behavior. Okay, we got this. Well, we can put it in our calculator again. Y equals, and then to get the fraction, we have to press alpha. Y equals enter. Okay, let's go. So we're going to go to Y equals, and we're going to type alpha Y equals enter. Then 6x, remember the x is this xt theta, 6x plus 5, all over 5, and then an x minus 7. Okay, let's go to our graph. My graph is still pretty zoomed out, but it's okay. Let me draw it. My graph looked like something like that. Yeah, okay. All right, let's remember what this question is asking for. It's asking for the limit, so that's the y value, when x is infinity. Well, let's remember where x is. X is the side-to-side axis. Side to side, yeah, okay. And when x is infinity, that's way over here to the right, because as we go along the axis on the right, we get 1, 2, 3, 4, 100, 1,000, whatever, infinity. Yeah, so this is when x is infinity. Okay, the question is, what's the y value of the curve right here? Well, let's look. Okay. As I get closer and closer and closer to when x is infinity, it looks like the y value is, I don't know, whatever this is. My graph, I gotta zoom out. Okay. Or zoom in. So my graph is zoomed too much, so I think I'm going to press zoom. Zoom. Then the number 2, then enter. Alright, this is better. Alright, and I want to know, when x is infinity over here, what is the y value of this curve? What is the y value? You see it? What? So what is that y value? Okay, and on your tests, I'm desperate. So if you're close, I'll give it to you. So it looks like this y value is, I don't know, maybe 1-ish. Yeah, okay. Technically, it's 1.16, blah, 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 but I'll show you how to get that in a minute. Okay, so it looks like this y value is about 1-ish. Yeah. So if you want to, you can put like 1.2. And I'll have to hand check that one. That says 1.2. Okay, the mathy way to do this is, if you have x approaches infinity, yeah, which we do, and this is the only problem that was x approaches infinity, that started with an equation. See, number 7, we started with an equation, but it says x approaches a number. Yeah, okay. So this is the only problem we've done that says the infinity. Okay, if x approaches infinity, you divide the numbers on the x. So what numbers are on our x's? 6 and 5. So we say 6 divided by 5. Holy poop, it's 1.2. I was just guessing on that 1.2 earlier. So we were correct. It is 1.2. And we could either kind of guess from the picture, or if you're not that great with the picture, we could just divide the numbers on the x's. It's kind of like we're finding the horizontal asymptote. All right, let's go. Let's take a break. Maybe please just